The world's deepest cave, the Krubera-Voronya system in the Caucasus, is a good example of the surprises one can find deep underground. A tiny, almost invisible entrance can actually lead thousands of meters deep. Each cave explorer is attracted to the unknown for a different reason. Biologists are interested in underground creatures, which are sometimes reminiscent of legendary monsters. Exploring isolated places is a formidable challenge everywhere. Cave and karst research is a demanding activity and often extremely risky. On our planet, the last little-known places can only be found in the deep sea or underground. Cave biologist Gergő Balázs, together with Jorge Perez Moreno in the driving seat, and the daydreaming David Brankovic, organized an expedition to the Mexican jungle to learn more about the ecosystem of its caves. Approaching a cave entrance is not an easy task, and explorers like to carry the most oddball tools to the most unlikely places. One of the most interesting questions of cave biology is what connection the inhabitants of absolute darkness have with each other and the outside world. Where do they and their nourishment come from? In underwater caves, researchers often gather data by analyzing the composition of the water. This time, David is using a specially developed remote-controlled sampler device. Most cave ecosystems are nurtured by organic material from above ground. In an almost entirely isolated environment, special species evolve which can't be found anywhere else. But even the most isolated places usually turn out to be connected to the surface in the end. Analysis of the collected animals complements the hydrochemical tests. But capturing tiny creatures underwater is a rather difficult task. Researchers are inclined to believe that discoveries await them in faraway places, but caves are unique in this respect too. Perhaps the best example of this is the hometown of David and Gergő, Budapest. Budapest is known as the City of Baths, and as many people know, the same thermal waters have also created remarkable caves under the city. Not many people are aware, however, that these subterranean passages under a metropolis of 2 million people hide secrets which inspire the imagination of scientists all around the world. The almost entirely residential district of Rózsadom, or Rose Hill, lies right next to the river Danube. Under it, we find Hungary's longest cave, the 30-kilometer-long Szépvölgyi cave system. One of Europe's most beautiful crystal caves can also be found here. The Józsefhegy cave was discovered during building works in 1984. It took the explorers months to clear the entrance. The descent can still hardly be called comfortable. but those who squeeze through the narrow passages and don't shy away from steep descents can admire a spectacle, and not just any spectacle. The 67-metre-long Kinigi railway station is one of the biggest hydrothermal chambers in the world, and its size is not the only breathtaking thing about it. The walls are covered with fragile formations or speleothems. To protect these crystals, some parts of the cave are closed off even to explorers. The passages of the József-hegy cave were formed hundreds of thousands of years ago, but deep under Rózsadomb there's a cave still in the process of formation. The Molnár János cave is entirely filled with thermal water. The two caves certainly belong to the same system, but the connecting passage has yet to be discovered. Gergő Balázs is on his way to the Molnár János cave, situated across from the Lukács baths. The little lake in front of the cave is visibly full of life. But what does a biologist do in total darkness underground? The unusual environment is a serious challenge for scientists too. Thorough preparations precede the exploration. Cave diving is a rather dangerous activity. In this extreme environment, only special creatures can survive. Gergő is looking for tiny cave crustaceans. Divers have come across all kinds of cave animals, but nobody really knows what species inhabit this cave. With the help of a pump, he's collecting a few specimens for further analysis. Scientists are particularly curious about how animals have populated these subterranean passages and how they can survive in places where no nutrients are visibly available. To find answers to these questions, we have to learn more about the processes which shape this cave and its fauna. Despite all their equipment, divers can only spend a few hours underwater, but this is enough for them to have a glimpse of times gone by. The story of the Molnár János cave started millions of years ago. The walls are decorated by fossils. This sea urchin perished around 40 million years ago. The clams and sea urchins, of course, did not live in this cave, so how did they get here if the nearest sea is hundreds of kilometers away? The answer lies in the diagenesis of the limestone which makes up Rózsadomb. Millions of years ago, the area of today's Hungary was covered by sea. The shells of clams, sea urchins and other animals with calcium carbonate skeletons have survived long after their hosts perished. Over the millennia, the sedimentary shells shattered, cemented, and eventually transformed into limestone. Ultimately, Rózsadomb is made of the residue of similar animals that live in the sea today. "400 kilometers from Budapest, the Adriatic Sea is a perfect place to meet these live animals. In a sea divers don't need as much equipment as in a cave dive, as long as they don't descend too deep. There's also a lot more chance to look around. Nonetheless, it takes time to notice the anemone shrimp hiding in this sea anemone. Soles almost entirely blend into the seabed. Other fish hide in the shells of perished urchins and are rather mistrustful of curious intruders. In fact, this empty-looking seabed is bursting with life. Sea urchins play an important role in processing the sediment, and this was already the case when the limestone of today's mountains was formed. Their skeletons, as we could see in the Molnár János cave, can survive for tens of millions of years. Walls at greater depths are home to amazingly beautiful corals. The orange moss animals or bryosia hiding in cavities also look familiar. We've seen their fossils too in the cave. Their dead skeletons can also be observed in the sea in their original state. In the littoral zone, underwater springs bring fresh water into the sea from the land. The sight of mixing waters is also familiar from the Molnár János cave. Moreover, the cave itself was widened to a passable size by the corrosive force of mixing waters. The cupolas on the walls are the most visible evidence of the so-called mixing corrosion. During millions of years, movement of the Earth's crust cracked fissures into the limestone. The upsurging thermal water enlarged these cracks into subterranean passages, precisely because of the corrosive force of mixing waters. Thus, the caves of the Buda thermal karst were not formed by descending rainwater, but rising thermal water. The water later receded and some of the passages dried out. The cave-forming effect of thermal water is most spectacular in the Józsefhegy cave of Rózsadomb. Gergő and other cavers squeeze through the narrow entrance to learn more about the formation of the cave system. They are accompanied by one of the discoverers, geologist Dr. Szabolcs Lélősi, a distinguished cave expert. As they get closer to the Kinizsi railway station, the character of the passages changes. Szabolcs has been to the cave hundreds of times and knows all its secrets. A good 500,000 years ago, this part of Budapest and the Buda Hills looked entirely different. Not only was the Molnár János cave entirely filled with thermal water, but so was the Józsefhegy cave, 100 meters above it.
Először ezek a feketés, vöröses-barna, mangán és vastartalmú vékony kérgek képződtek a kőzeten, aminek a kiválása hajdan itt a melegvízben tenyésző baktériumtelepekhez köthető.
If we look into the water of today's thermal springs, we can observe and collect these bacteria sites even just below the surface.
Amikor a vízszint még tovább süllyed, akkor pedig a felszínén el tudott távozni a széndioxid. Részint ilyen úgynevezett barlangi tutajok váltak ki a karsztvíz tetején, részint pedig a kőzetet mindenhol befogta egy több centiméter vastagságú kalcitkéreg. Amikor a víz tovább süllyedt lefelé, akkor a vízből felszálló pára, amely keveredett a beszivárgó vizekkel, újra elkezdte oldani a kőzetet, vízkőanyagát, és ahogy lefelé csordogált szép lassan a tó felé, újra fölmelegedett a vize, és egy lassú bepárodással kivált ez a borsókő, illetve a borsókő kristályok hegyén ezek a gyönyörű aragoni tűkristályok. Amikor az egyes kristályoknak a hossza 1-2 cm-es, és ilyen fürtöket alkotnak egymás hegyi hátán állnak szanaszéle a tű a térmiden irányába.
És a fagyik, amik ott vannak?
Azok normál cseppkő képződmények, amik szép lassan nőnek, és néhány ezer év alatt ezt a 5-6 cm-es vastagságot elérték.
Na jó, de mitől rózsaszín?
Egy kis vasoxidot old magába a víz. Ha nagyon kevés van, rózsaszínes lesz, ha kicsit több van benne, akkor barnás lesz, de van egészen vérvörös, sötét változat is.
In the Molnar János cave, we can't see such beautiful formations, as the cave is still filled with water, which also makes exploration rather difficult. Only the most experienced divers can explore underwater caves. Attila Hosszú and Laszlo Müllner are key figures in the recent activities taking place in the Molnar János cave. Before the dive, they check every piece of equipment. Underwater, the smallest mistake can have fatal consequences. The purpose of today's dive is to install the guideline in a newly discovered passage. Such complicated operations need thorough planning.
Hol hagytuk abban múltkor? Sajtinál.
Be voltunk a Sajtiba, ott, ahol alulról bejön az a kötél, mond 50 méterről. Körülbelül ott állomásőzik a dob.
Azt kéne tovább vinnünk teljesen eddig a pontig.
Akkor én tekerem a kötelet, te meg akkor fúrod, rögzíted, rákötök, hogy legyen meg a menekülő útvonal, hogyha bármi van.
Te mindenképpen kihúzod idáig a kötelet, én meg elkezdem fúrni a lekötéseket sorba, amelyiket fúrni kell, amit meg kötni kell, azt meg felkötöd.
At different depths, divers inhale different gas mixtures to make the dive more secure. When planning the composition of breathing gases, potential emergency situations also have to be considered.
Kifele útunk, az, ha sikerül rögzíteni itt a kötelet, akkor ezen az útvonalon keresztül, ha mégse sikerülne, akkor ezen a menekülő útvonalon. Oké, és akkor szerintem analizáljuk a palacjainkat, és mehetünk is.
They're analysing the composition of the breathing gases just before the dive. One sip of the wrong gas at the wrong depth is enough for the diver to lose consciousness. Apart from the many cylinders, they have to carry the tools needed to fix the rope, so they're using underwater scooters. When everything is in place, they can finally set off to explore the unknown depths. Divers communicate with hand signals while underwater. Before continuing, they have a last chat. Everything has to be right. Deep down in the cave, they have only each other to count on. they arrive at a new part of the cave, they put down the scooters. They've come far from the safety of the surface, but their real task is only just beginning. With this pneumatic drill, they can fix stands anywhere. The new rope begins where the old one ends. This way, divers can always find their way out. They have to move around carefully while swimming. A single thrust with their fins could stir up the fine sediment and reduce visibility, so they wouldn't be able to finish their task. The rope has to be fixed at a regular distance to ensure that it always remains tight and leads in the right direction. The air bubbles released from the pneumatic drills stir up the sediment. Only one screw needs to be fastened and the fix point is ready. The tightened rope will be a solid guideline for the divers. Visibility could drop so much that the explorers would not be able to find their way out without it. It also matters in which direction the exit is to be found, so divers attach arrows to the rope which always point towards the nearest exit. During the last few decades, 6 kilometers of new passages have been discovered, and explorers have reached a depth of 100 meters. Today, everything went according to plan, and quite a few meters of fixed rope were installed. But the dive is not yet over. To avoid decompression sickness, divers have to make lengthy decompression stops when ascending. During a deeper dive, these may take several hours, but the work done today has an additional benefit. The guideline ropes also help in the surveying of the cave. Sections of the rope can easily be measured. In the knowledge of the length, direction and gradient of rope sections, the spatial model of the guideline ropes can be built. This so-called polygon follows the cave passages, as the rope usually runs parallel with the walls. Following further measuring, walls can also be added to the model. Making a precise map, however, needs a lot of practice and is very time-consuming. Members of the mapping team, Peter Zsoldos and Viktor Pop, have worked on the Molnár János cave for years. They're measuring the lengths of each rope section with a regular tape measure, because laser measures simply don't work in the water. It's important that they read the measurement values precisely. Errors add up in the polygon and may significantly distort the map. After the length of a rope section, its direction has to be specified. Many people use digital compasses, but some divers swear by the traditional suspension compass. The measures are recorded on whiteboards and then processed by computers. From measuring the depths of each end of a rope section, its inclination can be calculated. Thus, all data is available to make the polygon. The survey not only helps with orientation and planning the dive, the map provides useful information for geologists keen to understand the secrets of cave formation and explorers searching for unknown passages. The map has an additional benefit. It helps to imagine the unimaginable. By integrating the model with a street map, one can clearly see the real size and extension of this underground wonderland. A piece of rope left in an old mapping point is an important meeting point for the permanent residents of the cave too. Following years of exploration by cave divers, biologists can eventually study these cave animals more thoroughly. But what kind of animals actually live in this cave? And how do they stay alive in this hostile environment? The answer can be found in the rigorous study of the collected specimens. Gerger places each crustacean captured into tiny vials and conserves them in alcohol. The primary examination takes place at the Department of Systematic Zoology and Ecology of Eötvös Loránd University of Budapest. The specimens have to be carefully prepared before they can be examined. Defining the species of these tiny animals needs great precision. To prepare the permanent slides, the exoskeletons of the animals have to be cleared of organic materials in a steaming potassium hydroxide bath. As cave animals are typically colorless, microscopic details are difficult to observe. By using a suitable dye, even the tiniest parts become distinguishable. When defining species, the most subtle details matter. Every appendage has to be made ready for examination. The lengthy process requires some dexterity. The prepared slide will be catalogued so that it can be compared and contrasted with the results of other studies. Some of the collected animals won't end up under the microscope. Geneticists of Florida International University will study them. Through the lenses of an optical microscope, the smallest details that differentiate species can be observed. Two of the crustacean specimens collected in the Molnár János cave appear to be previously unknown species. For absolute certainty, genetic tests are necessary. Jorge Luis Perez Moreno is a geneticist at Florida International University in Miami, Florida. This is one of the leading laboratories in the genetic study of crustaceans. They're looking for several answers in the Budapest samples. Genetic data support the hypothesis. These are indeed two new species. But researchers also want to know how these species ended up in the cave and how they're related to other species found elsewhere. Genetic similarities and differences provide clues about affinities with other species. The PCR machine-replicated DNA fragments can provide answers to several questions. Discovering two new species in the middle of a metropolis is quite unusual. But there's something else. The most exciting results are linked to an already known species. It turns out that the water louse found in the cave don't interbreed with their above-ground cousins. This means that we are witnessing the evolution of a brand new species. Visitors to the Hungarian Natural History Museum of Budapest are often unaware that beyond the exhibition space, serious scientific research is underway. Dr. Dorottya Angyal is a zoologist at the museum. Together with Gergő Balázs, she's scientifically describing the two new species. This time, she's applying a very different method compared to those in Miami. She's drawing the characteristics of the species by hand. Thanks to a clever optical system, she can see the slide and the drawing paper at the same time. This way, she can visualize characteristics which neither digital technology nor genetic analysis can, as only the human brain is capable of making the necessary distinctions. Applying old and new methods are equally important. Similar-looking creatures are often found to belong to different species, while animals belonging to the same species occasionally look very different because of their diverse habitats. Water louse, for instance, can be found in several caves, and while their appearance may vary, they don't always evolve into new species. For that to happen, the genetic mixing of different populations must stop. According to data, cave water louse in the Molnár János cave became isolated from above-ground populations 110,000 years ago. This coincides with an important glacial period. The split, therefore, was probably caused by the temporary sheer hostility of the outside world. Those specimens that had withdrawn to the cave could start their separate evolution. Adapting to the subterranean environment, they began to lose their color and redundant eyes, while their sensory tentacles and legs expanded. One thing is certain, the Ice Age is over, and water louse can manage outside as well. In the sunlit lake, they find ample nourishment, which is visible from their well-functioning digestive systems. But what do their subterranean cousins eat? Thermal water is from deep inside the Earth's crust, and organic materials from above ground can hardly reach the cave. For an answer, we have to learn more about how animals find nourishment. Rainforests are the richest habitats in the world. Trees using the sun's energy produce organic materials from carbon dioxide and water, which later serve as nourishment for numerous animals. Leaf cutter ants take advantage of this. They cut the leaves and carry them home to cultivate nutritious fungi on them. In the rainforest, every animal lives off the nourishment produced by plants, and this is true of the vast majority of animals on Earth. Almost all depend for their daily sustenance on organic materials produced by photosynthesis. Even notorious carnivores do this. They just wait for somebody else to process the plants for them first. Apart from rainforests, there are other ecosystems with a similar abundance of species. Tropical coral reefs are perhaps the most spectacular ones. We don't find huge underwater plants, but an invisible mass of microscopic algae use the sun's energy exactly the same way as trees in the rainforest. In the end, fish feeding on corals use the products of photosynthesis exactly like terrestrial animals. The whole system is sustained by sunlight. Naturally, there are animals which feed on others here too. Sharks, which are on top of the food chain, are known to be the most efficient predators of the seas. But how does this system work deeper in the water where there's no sunlight and photosynthesis? Traditional scuba diving gear limits sea explorations to -200 meters. To go deeper than this, one has to use a submarine. Cameraman Zsolt Sásty and photographer Daniel Szelmeczi are about to photograph the Empire of the Deep off Cocos Island in Costa Rica.
We go all the way to 200 meters in the platform.
Beyond the depth of 200 meters, total darkness awaits them. For navigation, they are entirely dependent on the onboard computers. Even at this depth, the upper world has an obvious effect on animals. This hooked shark could feel these effects more than skin deep. The palm leaf lying on the seabed demonstrates that organic matter can get even to deeper waters from the surface, providing nourishment to underwater animals. Despite total darkness, plenty of animals live here. Even if indirectly, however, they all survive because of sunlight. This submarine can only dive to a depth of 300 meters. Already at this depth, there are peculiar animals which look as if they're from a different planet. Deeper waters are explored by remote-operated vehicles. The robot of the Marum Institute of the University of Bremen is able to descend to thousands of meters deep. Animal communities around so-called black smokers, sort of thermal vents at thousands of meters deep, were only discovered at the end of the 20th century. These communities are often entirely independent of sunlight, as their food web doesn't rely on photosynthesis. Organic matter is produced by bacteria through a chemical process. The outcome of the so-called chemosynthesis is then used by many animals. Thus, deep-sea vents can sustain fully fledged ecosystems even without sunlight. Chemosynthesis is known from caves too, but it only rarely plays a defining role in the food web. Only a few caves are known worldwide where this is the case. It has occurred to researchers that the Molnar János cave could be one of them. David Brankovic, a researcher at the Texas University of Agriculture and Mechanics, is an expert in isolated ecosystems. He primarily studies Mexican caves, but when he heard about the discovery of a peculiar animal community in the Molnar János cave, he joined the research in his own hometown. He decided to thoroughly examine the ecological features of the Molnar János cave. David will take water samples for chemical analysis. Gergő will collect crustaceans again for isotope ratio analysis of their organic composition, which will shed light on where their nutrients came from. Sample collecting needs as much preparation as an exploratory dive. A mistake in the plan can risk more than the research results.
Ugye arra vagyunk kíváncsiak, hogy a barlangban élő egyedek azok honnan szerzik az energiaforrásaikat, honnan szerzik a tápanyagukat, akkor ezekkel a stabilizatópos szén és nitrogén vizsgálatokkal ezeket tök jól meg lehet nézni.
Jó, és akkor azt is kéne csinálni, nem, hogy oda megyünk egy helyre, akkor te először vízmintát veszel, mielőtt.
Igen, az lenne az ideális, hogy először vízminta, és akkor utána mehetünk kergetni az állatokat.
Once they attach all the necessary gear to themselves, they leave for the water. Thanks to decades of exploratory work in the cave, entering the water is rather comfortable. But down there, they will face a difficult task. Animals can't be found everywhere in the cave. They frequent zones where the thermal waters of different temperatures mix. Their time is also limited. Once they've used a third of their breathing gas, they have to make their way out. This is why it's so important to choose the locations precisely. Nevertheless, it's difficult to find just a few millimeter-long animals, even in known habitats. Thanks to underway explorations, the most important mixing zones are already known. David is using a lockable syringe to collect water samples for analysis. The researchers descend deeper and deeper. The more diverse the locations of their samples, the higher their chances to verify their hypotheses. Luckily, they bump into creatures at places where they were never seen before. It's important to have the appropriate number of specimens from each species because different species follow varied nourishment strategies. The sample trap of the pump is transparent, so scientists can verify on site whether they have captured the right species. David has been studying the animals of the Molnar János cave in various laboratories for months, but this is the first time he meets them live. After precisely recording the location of each sample, they make their way out of the cave. Solving the puzzles of darkness may make a great contribution to science. According to certain theories, chemosynthesis provided energy for the very first organisms at the beginning of life on Earth. If it turns out that similar mechanisms exist in the middle of a metropolis, researchers can study the characteristics of such systems at a more accessible location than in the deep sea. After returning to the surface, samples have to be secured as soon as possible. Samples destined for isotopic study mustn't be contaminated with organic matter from above ground, lest this leads to false results. What the data will unearth remains to be seen. David will soon return to Texas, and the isotopic studies will take place in a laboratory in Switzerland. They hope that the Mexico method will work for these samples too. Recently, biologists found a snail species in the Molnar János cave, which demonstrates that a complex ecosystem exists there. Both the snail and the cave crustaceans feed on bacteria. The cave was named after its first explorer, János Molnár. The 19th century chemist never saw the cave's passages. He proved its existence solely by hydrochemical analysis. Almost 150 years later, scientists are trying to unearth the cave's secrets in laboratories, just like he did. As the explorations advance, more and more secrets of the Molnar János cave come to light. One thing is certain: in this city of 2 million, the people of Budapest are walking on unique wonders. But the proximity of the city also impacts the caves. Analyses have shown traces of contamination in the cave from the municipal sewage system. The findings have also caught the attention of the international scientific community. Decades-long explorations do not end here. Researchers hope that by publishing their findings, they will contribute to the protection of the cave too.
Got it.